Good evening. Real one. Good evening.
Good evening.
Very good. Good evening. Today we have a treat. We have the chair of the School of Technology, Dr. Austin Cheney, coming to speak to us. He is a scholar, he is a scientist, he is a thinker, and he is a researcher. And we are fortunate to have him the chair heading our school. And he kindly accepted to come after hours to speak to us on research. And without much ado, I did this in the other class, but I wanted him to see the say hi that we have. So say hi.
Hi.
And I want you to wave at him and say hi to him.
Hi. Hi.
Very good. It's only you.
Thank you, Dr. Walby. I appreciate having the opportunity to talk to the class tonight. I'm just going to share a little bit of insight and maybe get the gears turning and get you to think a little bit and have some conversation, and we'll see where it leads. First thing I want to do is I've got a little clip here that I want you to watch, and you're supposed to count the number of passes. So everybody pay attention. You might want to turn.
This is an awareness test. How many passes does the team in white make?
Okay.
12.
12? Everybody get a different number?
15. I might have missed one.
What?
I might have missed one.
12, 13. Who says 13? Who says 12? Who doesn't have any idea?
I think the white sometimes was passed down to black.
11?
That's what
10?
Yeah.
More than 13?
15.
Okay, let's find out.
The answer is 13.
What did you say?
I said 12.
Oh, that's what you said. Okay, so we get to see how well people can pay attention, right?
But did you see the moonwalking bear?
What? How many people saw the bear? 1. Pay attention now. Okay. So, for your research, it's a playful video, but what does it mean? What do you gain from that you can apply to the research that you're learning about and the process of research?
Have to focus on more than one thing at a time.
Okay, have to focus on more than one thing at a time. And that's true of the human brain. Actually, we talk about people being able to multitask. You hear about that a lot.
Yeah.
That's a fallacy.
Yeah.
The human brain can only focus on one thing at a time. So really what you're doing is switching back and forth between multiple things. You can't ever really think about two things at once. Try to think about blue and red at the same time in your mind. It's impossible. So that's one point. What else? What about other things that would apply to your research or the research method? Some insights that you get from that exercise.
I would say dig deeper, keep finding things, try to keep searching for things.
Okay,
not just stay
so-
on
Details.
One, yeah,
Right, you get
Look into
fixated
more
on one
detail.
topic, you
Right.
can miss some other topics.
correct.
Very good. What else? There's another big lesson from that video.
We all may see things slightly different.
Yeah.
Okay,
People in the room didn't necessarily get the right number.
lots of different perspectives. Okay, that's another thing. One more key thing I want you to get out of that. As a researcher, what do? You go out and do what?
Search the
You
truth.
research, right? You look at other people's articles. Now, do you think that the other people that write articles have some specific approach or mindset or agenda in mind when they do research? Every
Yeah.
one of us does.
Yeah.
Okay, we all have biases,
Sure.
and when we write a paper, we write it with through our lens, our bias. And as a researcher, you're supposed to be the skeptic. You need to not necessarily listen to what the other person says, but think about it in the broader context and see the bigger picture. Okay? So when this video tells you to count the number of passes, what did you do?
Count the number.
You focused on the number of passes, didn't you? And one person didn't listen. I'm kidding. Okay? So very few people see the bear the first time they've seen that video. Very few. Okay? And the reason is, you're programmed, you're told up front, count the number of passes. So what do? You count the number of passes. So when you're reading a research article and they say this is the way it is, are you going to say, yep, that's the way it is because they said so? You got to be skeptical. So those are the lessons really that I want to give you from this awareness video. And I'm just going to follow up on a few research-related terminology, I guess, if you will, or things that you need to think about as you're pursuing research. And there are really three broad things that I want to talk about. Correlation and causation. Have you talked about that at all in here? No? Okay, well, we'll talk about that a little bit. What's the other things I'm going to talk about? I don't even remember.
Focus.
I will remember, yeah. I'm thinking about the video still. So you can't think about two things at once. I'm going to talk about generalizability. That'll be the last thing I talk about. And then the second thing I talk about will be data analysis. So causation, correlation, data analysis, and presenting data, which clearly is going to be important to many people researching in the technology area. And then generalizability of research. So let's talk about correlation first. So these are some different graphs that show correlation of data. So you've got two variables, an X and a Y, and they're related in some way, or they're not related. Let's find out. Well, as this variable goes up, what happens to this variable in the graph here? What's going on? What's the connection between the two variables here? When one goes up, what does the other one do? It goes up too. This is plotted data. So when this goes up, this one goes up. When this one's low, this one's low. So that's a strong positive correlation. If you get a lot of scatter in that data, that's not quite as strong. We call that a moderate positive correlation. So you still see a positive trend in that data, but there's more scatter than you see over here. Same thing, you can look at it from a negative perspective. There's a negative correlation. As X goes up, Y actually goes down in this case. Again, the data points are very tight, so you have a negative correlation that's fairly strong. Here you have a little more scatter, so it's a little weaker, or maybe a moderate negative correlation. Over here, X and Y, and you just have a bunch of dots randomly appearing. So there's no correlation in this case. And then down here you actually have a case where when a variable is low, when X is low, Y is fairly high, and then it drops down as X increases. And then after you get to a tipping point, Y actually starts to increase as X increases. So that's a curvilinear relationship. So there's all kinds of relationships that we look for with data when we're doing research and collecting information. And we're looking for these types of relationships. So that's what correlation is. Are there any questions that anybody doesn't understand about correlation of two variables?
Can we have some example of variables?
So,
Yes.
like if are you an engineer? You don't understand what viscosity
I'm a
is?
business graduate.
You know what viscosity is?
Thickness.
Yeah.
So if something has a low viscosity versus a high viscosity, so when temperature goes up, what does viscosity do generally? Up or down?
Yes.
So that's a relationship. That's the type of thing we're talking about with correlation. You might look at, I'm trying to think of a business type application here. So if I have one advertising campaign versus another, what's the correlation between the results in that advertising campaign?
Prices of goods go down and up with the marketing.
Okay, sure.
You put the marketing efforts on
The supply-demand curve.
Yes.
There's an example of a correlation.
All right.
Does that make sense?
Yes.
Okay. Very good. So anybody else have questions about correlations? So we're comparing two variables. All right, so one of the important things you need to realize is that correlation does not equal causation. So just because two variables are correlated, let me go back, x and y, doesn't mean when x increases, y is definitely going to increase. Doesn't mean x causes y to increase. And vice versa. Y doesn't cause x to increase necessarily. Okay? There's a number of potential reasons for that correlation between two variables. One could be A causes B. You know, again, A on the, let's say A on the x and B on the y. So A causes B. Another one could be B causes A. So it could be the inverse of what you assume if you assume a causation. It could be that A and B are interdependent. So maybe one going up causes the other one to go up, and maybe B going up causes A, and A going up causes B to go up too. So there's an interrelationship there. You know, again, you could think of that as in a marriage. How many of you are married? You? Okay, so if you're in a good mood, what does that tend to do for your spouse? Does your spouse get in a better mood generally or in a worse mood? Generally, they're going to follow you. So the same is true. The husband or the wife, you know, in any relationship, you tend to feed off of each other. So that would be a good example of this A and B causing each other. There's an interreaction there. A and B are consequences of a common cause, but they aren't really related to each other necessarily. So, let me think of something practical there for, anybody think of anything where that might be the case? So there's some outlying cause that causes two variables to change at the same time, but those variables aren't necessarily related to each other.
There could be in the market the change of style in the people. They cause the products, the change in the demand of the product. Like style of the women's mostly changes.
Okay, they change the type of thing they like to wear. Is that what you're saying?
Yes.
Okay.
And what the companies do, companies start producing those things.
Okay.
So this may be the example
Of which?
of the A and B are consequences the common cause.
So
but
what's
not
the
cause each
what's
other.
the common cause and what's A and B in that scenario?
In this, the style of a woman changes.
Would be what?
They are going to change their preference
Okay. So
Uh,
that's the
from
cause.
the-
You're saying
yes.
that's the common cause. What are
between
the
woman and the producer of their product, of the clothing, producers of the clothing.
so the women wear something different, and the producer produces
And
something different.
yeah, they produce more products of that type.
I'm still struggling to try to see what you're. What are the A and B in that case, and what is the
A is a woman.
Common cause.
A is a woman which wants different products,
okay?
and B is the producer.
Okay.
Who produces the clothing.
Right.
Now, what happens is they have a common cause. He is a producer and she wears
Right.
the clothes. So the producer is going to produce different products to sell the woman.
Who can help me? Who understands that?
Are you on the fourth one?
I'm on the fourth one.
Yeah. Well, an easy way for me to look at that one would be your car battery's dead, your lights don't work and it won't start. Your lights don't work not because it won't start. And then likewise, your lights aren't working.
Okay. Everybody hear
They're
that
not connected.
example?
They're both connected to the battery.
Okay, so the car won't start and the lights don't work. So those two are correlated. And so you say, well, the lights won't work because the car won't start. Right?
Well, I'm saying the battery's dead.
But the battery's dead is the cause.
Right, but they're both.
Okay, but that's the common cause that causes A and B to happen at the same time, even though A and B aren't necessarily interrelated. So the lights don't work and the car won't start. Okay, the car won't start because the lights aren't working? Okay, it's because the battery's dead. So the battery you didn't study, you studied A and B, they're correlated, but you didn't collect data on the battery, so you don't know that that's really the common cause of why these two things are related. Very good example. Is everybody clear on that now? Does that make sense? Okay, excellent. See, I knew you'd have great ideas in here. I wouldn't even have to come up with examples, you come up with them for me. I appreciate that. Okay, and the last one, there's really no connection at all between A and B. It's just a coincidental correlation. So if you did the same study 50 times on 50 different sets of data, there might only be a correlation one time, because statistically when you collect data, it's a random sample, and there's a possibility you get a sample that shows correlation when there really isn't one. Does that make sense? Okay, so correlation does not equal causation. Is that clear to everybody? We'll move on. We'll talk about it a little bit more. When you're trying to do a research study and come up with some causal determination, if that's your hypothesis, say, your alternative hypothesis that you're trying to disprove the null hypothesis to prove some correlation, let's say, and turn that correlation into a causation, you have to look at several things. First thing, the key thing for any research study, is you have some theoretical underpinnings for that causation to be true. Okay? If you don't have underlying theories that justify or explain that, you're starting out with a weak foundation. Okay? Again, if you just start collecting data, and people started collecting data and saying, why are you taking me? No, no, if you're collecting data and trying to say that evolution happens, but you don't have an evolution theory to back that up, okay? It's the grounding. You've got to have some theoretical hypothesis or understanding of whatever you're studying, backed up from previous work that's been done or some new groundbreaking theory that you've come up with that justifies that causation in your correlation analysis. The second thing that has to be true is there has to be a temporal precedence. You can't say A causes B if B happened before A. Okay? Does that make sense? So I can't say that sweating causes me to exercise, right? Because the sweating happened after I exercised, right? So that's the temporal precedence rule. So these are all things you have to look at when you're trying to say, and again, it all goes back to that awareness test. When you're looking at some research results and the conclusions someone makes based on the data they've collected and the analysis that they've done, does it make sense? Do they follow these rules? Or are they breaking out of some of these rules? Next one is cause and effect have to vary with each other. So there has to be that relationship here, 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 here. If you have that kind of data result, can there be causation? You got to have correlation. That's what I'm talking about here with covariation. When one goes up, the other one has to do something, either up or down. It has to follow a pattern. Okay, so there has to be some kind of correlation, or you can't say there's causation. You got to have correlation. That's a minimum criteria. And the last one here is one that, as a researcher, you have to really spend some time thinking about. Are there other things that could explain that result? Are there other things that can explain it? So, who can come up with some examples there of some research assumption that's out there that there are alternative explanations for? Maybe there's some skeptics, we'll call them, in the scientific community that say that isn't necessarily true.
Evolutionists and
theories.
creationists.
What?
Evolutionists and creationists.
Very good. So there's this evolution theory out there, and they say that everything started as some primordial organism, okay? And we became humans from that. And there's other people that say that's not true. And there are scientists, biologists that believe in creationism, okay? So are there plausible explanations? You know, again, you can argue whether that's plausible or implausible, the two viewpoints. But again, it's two different perspectives. And you can have that happen from a more accepted scientific approach as well. So, you know, are there plausible alternative explanations for the results that you got? So those are the things you need to be thinking about when you're doing research. Okay, one of the many things you need to think about. So here's an example down here. So the data is people who consume more ice cream are more likely to be attacked by sharks. So people who consume more ice cream have higher incidence of shark attacks. So we conclude that, well, higher ice cream consumption leads to a higher risk of shark attack. Does that make sense? Yeah, that seems kind of silly. But again, when you're looking at research papers and you see their conclusions, it's not going to be this obvious, but you really need to drill down and look at these things up here and see whether what they conclude really makes sense. Or are there other plausible explanations? Or did they look at this temporal precedence? Or is there an alternative theory that would explain it in a different way? Okay?
Could this be applied to global warming thing? I mean, some people, scientists say...
We will see. I'm going to actually talk about global warming a little bit later.
Very good.
Okay, so the second thing I want to talk about, correlation causation was number one. Second thing is looking at data. You're going to be looking at a lot of data in your papers that you review probably. Not all of you maybe, but most of you. So we're going to look at some different ways that data is presented. It could be that you're seeing it in a paper or you're preparing to present data. And again, my purpose of having this discussion with you is so that you present data properly and don't try to mislead people and try to do things on the up and up, let's put it that way. Okay? So here's a set of data. And let's say I'm a salesperson. I'm the manager of sales for a company, and I want to show that we've done a really good job. Okay? So I'm presenting to the CEO of the company, and I'm showing how our sales have drastically improved. Dramatic improvement from October to December. Look at this. December is almost double, it's over double from October, right? What's the issue you see with that presentation of the data?
Scale's way off.
What do you mean the scale's way off?
Starting from 74 and then building only to 82.
Oh, okay, so you didn't start at 0. If you look at the data starting from 0, this is the way it looks. Oh, yeah. Looks a lot different, doesn't it? That's not going to impress the CEO. I think I'll do it the other way. All right, so there's one obvious, and we're going to talk about different types of data presentation. So another possibility would be axis changes. You see this data, the x-axis is the same for all of them. It's the same data, but does it look a lot different in each of those pictures? You know, you've got a really low slope here, a really high slope here, it seems like. And again, it's, you know, you present data and sure you might have the numbers there, or they can look at the numbers, but if you're trying to persuade an audience that's looking at your paper or viewing your presentation to think a certain way, if I want to show that there's some high rate of change going on, which one am I going to choose? Well, I'm going to choose to present it this way because it looks dramatic, right? So, but if I want to minimize it and seem like it doesn't have much effect at all, I'm going to present it this way.
Stock
I really
market.
wouldn't do that, but that's what someone will tend to do. So you want to be skeptical. You want to look at these things and really analyze it when you see data. And it's hard to do when someone's giving a presentation and they flash by a slide and say a bunch of fancy words and then they're on to the next slide. You're like, wait a second. But look at the data. When you're looking at a research paper, you've got time to really scrutinize and see how they present data and say, okay, which scale are they really using here? 10 to 12 on the Y, or 0 to 12, 0 to 10, 0 to 30. It's the same data, it's just shown differently.
It is something like stock market. They want to sell this product, so they make it like this.
Yeah, you're gonna make it seem like it's going up like crazy. Another one might be scaling. Okay, so you compare bananas, apples, and cherries. How many do you have of each? Same, but it looks like the cherries, you got a lot less of them, don't you? When, you know, in reality, if you're doing graphical type presentation, you see the same thing with like 2D and 3, you know, this is a 2D and 3D presentation of data. Like if you do a pie chart and you do a pie chart in 2D, you know, it's very clear to see the percentages. But now you see a lot of this 3D presenting now where they, you know, make this pie chart that shows like this on a slide. Now, all of a sudden, it twists around all the picture and image in your mind, and it's hard to see those percentages as clearly. So that's another way you could use graphics or scaling to modify the way data looks. Here's another example that sometimes you'll see where they mess around with scales. You know, they'll show a skip in the data and just show this data then, so they didn't show what was going on here. Now, sometimes they do that for a reason. Maybe that data is not relevant, whatever reason, but anytime you see something like this, you should think about it and really scrutinize, okay, did they do that for a practical reason, or is there something that's getting hidden here that I'm not seeing? So you should always be skeptical when you look at data and make sure that it's accurate presentation. Or representative presentation, I should say. You know, again, this may not be inaccurate data that they present, but if someone's doing this kind of stuff with the axes, you start asking questions. You should always start asking questions. Look at this, global warming. How many people remember this slide? How many people saw Inconvenient Truth, that movie? 1, 2, just 2 people? Well, I watched this video, right? And I remember when I first saw the video, and I saw this slide. And some questions came to my mind when I saw that slide. And it's comparing global temperatures to CO2 levels. And this graph goes back like 650,000 years or something like that. How did they get data on CO2 levels 650,000 years ago? Well, the way they collected that data, they took ice cores from like the Antarctic or something, and they measured CO2 levels in these ice cores. So first of all, there are assumptions being made. When did those ice cores form? You know, and that CO2 represents the CO2 on the planet. That CO2 in the ice represents the whole CO2 in the planet. So there's one assumption, okay? And another thing I noticed here, I saw this dramatic increase in CO2. This is what we're doing, you know, we're producing a lot more man-made CO2. And yet, this hasn't gone up. So I started, well, why didn't he talk about that at all? Why didn't he talk about, here's where we're at now, I think, and here's where we're projected to be in 10 years or something. But if we had this dramatic increase here, why did this not go up? So I had some questions, and then other people did further analysis of that data. And again, the argument here, is there a correlation between temperature and CO2 in this graph? Yeah, it seems to follow. When one goes down, one goes up. They seem to follow a similar trend. What are some of the other assumptions you make with causation? Because the hypothesis that was proposed by Al Gore when he presented this on the video was rising CO2 levels cause the temperature to rise. And that's been, for 650,000 years, that's been true. What are the other assumptions with causation that we talked about? Remember, there are 4 things. First one's theoretical underpinnings. Okay, yeah, maybe you had that. Second one was what? Temporal precedence. Is there temporal precedence in this graph? Can you even tell with that huge scale?
No.
Okay, so let's take a look at that. Now this is, again, you can, whether it's a skeptic or whatever you want to call it, took this same data and took out a subsection of it and overlaid the 2 plots and actually showed that CO2 levels changed after the temperature changed in many cases. Okay? So it was the inverse relationship. Instead of A causing B, it was B causing A, is what they're saying. Again, you see lots of data presented out there. You're going to choose one side or the other, but collect as many facts as you can before you do it. Okay? Any questions on this?
Is this movie available somewhere?
Inconvenient Truth, you can probably rent. The library probably has it here, I would guess.
Convenient
Charleston
Truth.
Library.
Okay.
Probably read it from there. What else did I want to say about this? I thought I had one more thing to say. Maybe not. Okay, so did Al Gore have an agenda?
Yeah.
Sure he did. That doesn't mean what he said wasn't true. I'm not saying it was or wasn't. All I'm saying is there are different perspectives, and keep an open mind and be skeptical of any data you see presented, especially when someone has an agenda when they're presenting data. And you knew that there was an agenda here. Okay? Other questions? There's actually data out there, scientific presentation that says that the global temperature actually leads to increased CO2. So when the temperature of the globe goes up, CO2 is actually naturally produced. So there's scientific evidence of that. So again, which side is it on? I don't know. Don't know the answer for sure. And many scientists really don't know the answer, but again, they approach it from a lens, and their lens is a certain belief system. They believe, yes, it is happening, so they're going to jump on it. And someone else believes it's not happening, so they're going to try to find everything they can to say it doesn't happen. You know, a lot of times it's interesting, you know, when you're in grade school, junior high, and high school, they present a lot of theories in chemistry class, for instance. I don't remember specific ones, but I remember a lot of theories were presented as this is the way it is, this is fact. And then you get to college and I study the same thing, and they talk about it and it'd be like, well, it's not a fact that it's that way, that's a theory. And we're just, you know, creating a model to represent what we think is really happening. So, you know, again, if it's a theory versus real data, if you see a number 5 in front of you, it's a number 5, but you know, that's a fact. But you know, many times the theory of evolution is presented a lot of times as a fact. But there are people that believe it's not a fact, and there isn't really data out there that shows that change from one species to another. They haven't collected data to prove that. They got all kinds of data around it, but the core data to show that transition from one species like a cat to a dog, how did that happen? I don't know. Again, I'm not an evolutionary biologist, so I'm not going to pretend to know all the answers to that.
We didn't talk about that together, but last week we saw Mr. Dawkins, what was his name? Dr. Dawkins.
Dr. who?
Dawkins.
Dawkins. Oh, yeah.
The big evolutionist. And he was asked one question after all these years. Give us one example that this thing happened. And he took how long to answer?
Well, you know, my biggest question about evolution, again, I don't know the answer, but my biggest question is, okay, so the evolution theory is you had, whatever, say an ape, and it evolved into man, right? Is that accurate? Somebody who knows evolutionary theory well. What?
That's really not what Dawkins is saying. Dawkins is saying all creatures are modern creatures. And I don't agree with Dawkins, not one word of what he says.
But guess what? He changed what he said before. He was always said the other thing, but when he was...
Right. But yeah, in that explanation, the question was, have you ever seen evidence that a mutation causes information in the, what's the word I'm looking for, the genome?
Genome.
Genome, G-E-N-O-M-E.
Yeah.
The mutation causes an increase in the information, which would have to happen for one species to change into, for DNA to change from one thing to another. That would have to happen in these mutations. and he answered a question, but it wasn't the question that was asked.
You just said that we're all.
Again, you know, scientists, you know, you like to think everybody's objective, okay? You like to think scientists are objective. But every person has a lens that a belief system that they have. And when they go out and do research, they're collecting data to try to prove what they already believe most of the time.
Well, if you're an evolutionary biologist, you probably already eliminated every other possibility anyway, haven't you?
Well, in your mind you have, yeah. And that's the way when you do research, everybody has a tendency to drift toward that. So, again, try to be as objective as possible when you're looking at your
What are your
studies.
thoughts? You're gonna say.
What's it? Oh, my question about evolution is, okay, so you have I don't know. Can dogs and cats mate? And this is maybe not the best example. Can apes and humans mate?
They can mate.
And produce offspring?
Nah, that's what.
Okay,
They can mate,
so
but they can't.
if you got an ape and you're saying the ape turned into a human, how did that transition happen? And how did, okay, an ape has a baby and now it's a human baby or something in between ape and human, and now if it's genetically different enough, it can't mate and produce more offspring of the same kind because it can't mate with something that's a different species and produce offspring. I haven't seen an answer to that. Maybe it's out there. I don't know. But that's the question I always have with evolution. I'd like to, if anybody knows that answer, I'll listen. So, okay, let's move on. Again, I'm not, here to preach to you or anything. So, last thing is generalization of results. So you collect data, you design some study, and you go collect data to prove something. And usually, typically, in order to collect data and really justify that you created some new piece of information, you're going to do a very narrow study. You're going to have a very narrow hypothesis. Okay? So, in this case, I'll give you a minute to read through this. Just go ahead and read through these 3 paragraphs.
Can you ask someone to read it loud because it's kind of small? Anybody can read it.
Who wants to read this paragraph for me?
In a California gourmet market, Professor
Louder, please.
Iyengar.
Okay. In a California gourmet market, Professor Iyengar and her research assistants set up a booth of samples of Willikin and Sons jams. Every few hours, they switched from offering a selection of 24 jams to a group of 6 jams. On average, customers tasted 2 jams, regardless of the size of the assortment, and each one received a coupon good for $1 off 1 Willikin and Sons jam. Here's the interesting part. 60% of customers were drawn to the large assortment, while only 40% stopped by the small one. But 30% of the people who had sampled from the small assortment decided to buy jam, while only 3% of those confronted with the 24 jams purchased a jar. The study raised the hypothesis that the presence of choice might be appealing as a theory, Professor Iyengar said last year, but in reality, people might find more and more choice to actually be debilitating.
So, one study of these jams from this company that I've never heard of. I don't know. Has anybody heard of this company? Okay. And apparently they have lots of different flavors because, 24 jams. That's a lot. I'm usually looking for grape. That's the only thing I want. But anyway, so the conclusion was, you get all these choices, you're less likely to buy it because it's just too overwhelming, too many choices out there, so you just don't buy it. Now, how many people say there are too many choices of automobiles out there, too many colors, styles, brands, varieties? I'm just not going to buy a car. So is that a valid conclusion to get from this study? And again, what's interesting about this is a lot of times you'll see this, so be very skeptical. The news media picks up on some research study that was done. And even if the researcher didn't conclude something that they said, well, if you generalize this study, it could mean this, that doesn't mean it does mean that, okay? And the news media grab a hold of it, and then they publish. You'll see articles on the web, or you'll see TV, you'll see, the news media talking about it. Oh, well, this causes cancer. Okay, peanut butter causes cancer. I think there was a study that actually showed that. Peanut butter, back in the 70s maybe. Peanut butter causes cancer, so they take these rats and give them, way more peanut butter than anybody would ever eat in a lifetime, and the rat gets cancer, so now peanut butter causes cancer. Again, look at how they overgeneralize the study, and particularly news media don't have scientific backgrounds. You'll see that a lot, where they take results of some scientific research that was done, they publish an article, news media grabs a hold of it and overgeneralize it. It applies to everything. Okay? So here's another article on that same study. So somebody up here, you want to read that?
A good example is the work on the too much choice effect by Sheena
Iyengar. This is the same study.
The famous jam in supermarket study. This is a great study and the results are very important. However, if you read the paper carefully, you will see that the effect is very specific and that the authors were very particular in the way they conducted the study. For example, all the jams were from a single brand and only unfamiliar flavors were selected. Yet after the paper was published and received a lot of attention, the fine prints of the study, which the authors carefully disclosed in the paper, were quickly forgotten and the field began to take it for granted that consumers did not like when they have too much choice. It turns out, however, that the effect is very fickle. In a meta-analysis by Shibin and colleagues, 2010, the basic effect was found in only a small number of studies. The reverse effect was found in an equal number of studies, and the majority of studies showed no significant effect.
Does anybody know what meta-analysis is?
It's analysis of an analysis.
Right, it's a study of studies. So you've got a bunch of studies that have been done in small, narrow groups, like this JAM study, okay, on the same topic. And you're going to collect all the results, all of those, and compare them. So that's what they did in this study in 2010. And they found that basically you've got some that say yes, some that say no, and some that say nothing. Okay? And it's about equal. Actually, most showed no effect. So, again, if you see data presented and you see conclusions, especially in the non-scientific arena, researchers love it when they write an article. If you look up this lady, Iyengar, if you type that name into the web, you're going to find all kinds of stuff about her presenting, and she's probably getting paid tons of money to go talk at places about this being true globally, So they love it when their research gets picked up like that and generalized, because they get popular off of it, okay? They make money off of it. So they're not going to come out and refute it because it's counterproductive for them, Anyway, when you see studies, they make conclusions, make sure they're really concluding based on the study they looked at, not generalizing to the whole world, or to every product that's out there. So, just in conclusion, kind of wrapping things up, thinking back to that video we watched in the beginning, looking at the basketball passes, be open-minded, but be skeptical too. You got to do both of those things. You think about someone being open-minded, what does that mean? It means you're willing to consider new ideas, right? But skeptical means, can you do both? Can you be both of these things? Sure. You can consider new ideas, but scrutinize them. Think about them. Do they make sense? Is the information that's out there already that has been collected and shown, does it support the idea or not? Okay? So hopefully some of those things will help you in your research studies. You got some papers, you're doing this and writing your papers.
Any questions to Dr. Cheney? Any questions? I have two questions. If you don't start, I'll start. So, one question is about bias. Bias is a natural thing in every human being. We are biased to things we like or think or whatever, perceive. But for research, bias can poison the research. How
Absolutely.
would you advise the researcher to be fair? And I mean, we can't take ourselves from our biases, but how can you balance this?
That's a good question. Again, I guess bias and ethics are two different things, but you see some cases where data has been collected and presented that wasn't really all the data, or it wasn't presented properly. That's an ethical issue.
That's
Certainly you
intentional.
want to stay away from that.
That's intentional.
But again, it comes back to that, keep an open mind, but be skeptical. So when you collect your own data, be skeptical of the results. Scrutinize, if the results show what you thought was going to happen, be skeptical of it. Are there any other possible reasons those results could have supported your theory? Are there, the other piece you can do is you can drill down a lot of times. You get data and there's a lot of different variables that you looked at, and drilling down to the data, you might find things that you didn't expect to find if you're skeptical of your own data and really scrutinize it. So, don't just take a superficial view of your results and write that up. Look at, the hidden things, the things you weren't expecting.
Any other question? I have a follow-up question for this. When we do the research, we are asked to have a hypothesis and predict approximately, to predict what could be the outcome tentatively.
Right?
How would you balance this with bias? I mean, are they against each other? Because some people say, I will not have a premeditated idea. I will start just blindfolded, and whatever the results are. But the other side say, no, you have to have something. Otherwise,
Yeah. It's hard to design a study if you don't have any expectation of what you might find. So, there's a lot of existing theories in all different fields that are out there in the literature. And so if you have interest in one particular thing, there might be 3 or 4 or more theories out there that are written up in other research studies, related to that particular study. So you need to look at those theories and look, there's going to be some bias in the decision of which theory you think makes the most sense and which one you think is going to predict your results best. Okay? And then if the results don't come out the way you expected, you have to look and try to explain, why do you think that didn't happen?
does it need courage?
Is there a mistake in the way you collected the data? Or designed the research study?
I have a question. When you go to test data, if you have someone else's report and you do it the exact same way, there's nothing wrong with that really, because your bias would be different from theirs. When they do like an experiment and how they set up an experiment.
Okay.
Because it's supposed to be repeatable.
Right.
So if you did it and you got different results.
And you see that a lot in the scientific community. They'll do studies and, it'll be repeated somewhere, but maybe they did something differently. Or again, you looked at that causation and correlation, and one of the possibilities was it just happened by chance. That there's not a real relationship there, but the data in this particular study showed it, and 100 other ones that were done to repeat it didn't confirm it. So that's possible, and it happens in the scientific community.
Okay.
And I can't think of it. I know there have been some in the physics arena like that, but I can't think of any off the top of my head.
What about the control engine? They have that.
Yeah, it lasts forever.
Yeah.
110% efficiency.
Dr. Cheney would be happy to answer a question from India. How about that? India. Okay, go Pakistan.
Yes.
Okay, perfect. It's near enough.
Yes.
Prepare
Actually, I
India,
am
please.
conducting a small research given by my professor. So, keeping in view today's presentation,
Right?
I am going to change my mind because we have to be open-minded and skeptical, as you told right now. So, I have a topic that is human trafficking.
Please listen. Someone be
I have
respectful.
a topic that is human trafficking.
Okay.
Now, human trafficking is a broad term, and it has a lot of reasons which make it happen.
Right?
So now, my question is how to be open-minded and skeptical in this scenario when there are maybe hundreds of reasons.
Yeah. Are there previous studies on it?
Yes.
Are they looking at what you're looking at, or something similar to what you're looking at?
I'm working on the developing the hypothesis.
Of what causes it?
Yes.
What causes human
Yes.
trafficking?
Yep.
Okay.
So keeping
Have there
in
been
view
any other studies
today,
related to that?
yes, we have a lot.
Okay.
Now, even the fights among the wife and a husband can cause the human trafficking.
Okay.
There is a possibility.
It's a possibility.
It's a possibility. And on the other hand, we have hundreds more reasons that cause human trafficking. Now, keeping in view that today's presentation, how I'm gonna be skeptical and not open-minded.
You know, again, you have to decide what you think are the key causes or the things that maybe have the greatest impact. When you do analysis and research, a lot of times, you know, again, we didn't get into complicated types of scenarios of data analysis, but you can do regression analysis where you compare some output variable y to 5 or 6 or 7 or 8 different potential independent variables, the x variables. So, you know, maybe you'll collect data on 5 or 10 different things
Okay.
and analyze all that data and then pull out the ones that come out significant in your statistical analysis. So maybe the
All right.
fight between the wife and husband becomes insignificant. I'm not saying it doesn't cause anything, but it just doesn't cause enough variation in human trafficking to be worth looking at. You're trying to find the variables that have the highest impact on
Okay.
on Y.
On the majority.
Yeah. What are the things statistically from this group that you're analyzing? What are the things that have the most impact on human trafficking? That's what you're looking for.
Yes.
You know, what are the ones that have the most influence? And it might be one variable, it might be 2, 3, 4 variables,
All right.
you know, that add up.
Thank you.
And again, some of your studies, you know, all these variables may only cause 10% of the variation in the trafficking,
Correct.
which is your Y variable.
Correct.
Okay. In other cases, 1 or 2 variables might cause 90% of the variation in a Y.
Yes.
So, you know, again, every study is different. So, I can't know what the
I got it.
details are for your study, but
I'm a very
it could be
basic stage.
interesting.
I'm a very basic stage with my professor. I'm working on a small mini proposal. This is the start of my study.
Good.
Yes.
Very good.
So-
Now we have Pakistan. We need India. Where is India? India. Who is India? Question from India. You came all the way from Hyderabad. You have a question. India. Research. Not ready? Okay. So we'll let you pass this time. Dr. Cheney would have loved to shake hands with all of you, but I'm asking him to shake hands with only one student. You stand up. You stand up. You stand up. And I'll tell him why I'm saying that. I shared with Dr. Cheney the silly questions that we had researched, the sheet of silly questions, the topics. And we had almost 60% of the students feeling weird about it, but they didn't express it. And we have almost 40% fell in the trap. So we had fun with it. The only one who exploded was this guy. Tell him your name and shake his hand.
Nagarjuna Sai.
Pardon?
Nagarjuna Sai.
Nada?
Nagarjuna.
Nagar?
Nagarjuna.
Nagarjuna?
Yeah.
He stood up here and said, these questions are not good.
That's good. Somebody spoke out.
Very good.
It's good to call the professors out once in a while.
Very good.
Try to pull one over on you.
Would you please join me in thanking Dr. Cheney by giving him a hand, please?
Thank you so much. Thank you for having me.
Okay.